Okay, with apologies. Um, the whole thing of the block sitting on a post is pretty easy to visualize anyway, so I think you probably picked that up. You know, block goes out here and falls 1.4 meters as a projectile. You couldn't see all of this, but it related to this, and this is what I just got done talking about, so hopefully you have that idea. Again, how far do we go up the incline? We go up the incline until we've lost all our kinetic energy and it's been converted to potential energy. You'll have a negative change in kinetic, the corresponding positive change in potential energy. And the potential energy is mg delta y, not because of a formula mgh, but because that's equal and opposite to the work done by gravity on the mass. Okay? And we define potential energy in this course as change in potential energy is equal and opposite to the work done by the conservative force. Forcing you to consider what the conservative force is. And if it isn't gravity, then mgh has nothing to do with anything. And if it's gravity anywhere except in the vicinity of the surface of the Earth, it's not mgh either, okay? It's only mgh if you're talking about gravity in a realm where gravity stays uniform, okay? And if the force isn't gravity, it's definitely not mgh, so we want to stay away from that. Anyhow, using conservation of energy, you can then figure out how much higher this thing has to go, and you can figure out how far it has to go at this angle to get that much higher. It can be analyzed in a number of different ways. Okay, now, what I started to do until I realized that this board had been displaced to the left because of what we were doing previously, block suspended from a string, gets hit by the bullet, gets its 5 meter per second velocity, and swings out until the change in potential energy is equal and opposite to the change in kinetic energy. The kinetic energy will be the energy of this mass at 5 meters per second, and it's going to go higher until its potential energy is changed by an equal and opposite amount. Kinetic energy goes from whatever it is to 0. Potential energy goes from whatever it is here to that much more. So you got to understand, you know, how far a thing goes up if it goes through a certain angle along the surface. So you can figure out how far it swings in this direction to get up that much higher. But that's pretty simple geometry of the circle. I don't think anybody's going to have a lot of trouble with that. Now, I mentioned these problems, as I said, in class, because these situations are typical of the kind of situations that you're going to get in your homework on momentum conservation. You know, something colliding, changing the momentum of some other object, or being embedded in an object and moving. How far does it slide if the coefficient of friction is such and such? How far does it raise up if it's suspended from a string? How far did it go up an incline? You know, what happens with the energy it obtains. So you use impulse momentum, or conservation of momentum equivalently, to figure out velocities, and then use conservation of energy to figure out what happens with that velocity.